Clarifications, range selection, and measurement duration. Sometimes even experienced users of laser measurement equipment run across issues that, although basic, need to be clarified. In this video, we'll have a look at two such issues. How do I know what range or scale to set my power or energy meter to, and what happens if I go over range? First of all, in general, each given range represents one level of gain of an internal amplifier. The electronics, as always, have a limited dynamic range. If the measured signal is too low, in other words near the bottom of the range, then it may be lost in the noise and the reading will be inaccurate and noisy. If it's too high, near the top of the range or beyond, there may be saturation issues. To give an instrument a usefully wide dynamic range, multiple scales or ranges are used. Switching from range to range can be automatic using auto range or manual. Auto ranging simply starts automatically at the least sensitive range and works its way down the ranges, sampling the signal as it goes until it finds a range at which the signal is properly detected. Note, by the way, that only in power mode is auto ranging available. If we're working like this in single shot energy mode, there is no auto ranging, simply because when we're measuring a single pulse, the instrument has no opportunity to work its way down the ranges, sampling the signal as it goes. So when setting the range manually, how do you know which range to choose? Very simply, you follow the same method that auto ranging uses. Start at the highest likely range, and if the reading is less than 10% of full scale, switch downward to more sensitive ranges. You want to work at the most sensitive range that's still above the maximum expected reading. We're often asked, what happens if the measurement is over the top of the given range? I know I should switch to a higher range, but meanwhile, what will I see? Let's clarify this. If the reading is, as you see here, up to 10% over, you'll get a reading together with the warning over in uppercase letters. More than 10% over range, you'll get just the warning over in lowercase letters with no reading. In certain cases, when the sensor input is so high that the detector saturates, you might get a SAT warning instead of a lowercase over warning. This may, by the way, occur even before the reading is over range. Also, in certain rare cases, if the energy is way above the maximum for the given range, you might get a reading that will be nonsensical without any over-range indication. Obviously, such a drastic mismatch of actual energy with selected instrument energy range setting would be noticed by the user, but I mention it here for completeness anyway. We're of course not talking about being so far over range as to cause damage. That's a separate issue. Note that smart sensors in general are always defined such that their highest range matches their highest possible measurable power or energy. They're meant, after all, for universal use. OEM sensors, on the other hand, are defined according to customer requirements, and their maximum range might not be a technical maximum, but perhaps merely a specified maximum. OEM sensors, after all, are defined for a specific application and not for universal use, so their specifications reflect this. If you have a specific question about an OEM sensor, ask Ophir either directly or via your local Ophir representative. Question: how long can my measurement duration be? Sensors are normally designed to work at their maximum rated power continuously. Each sensor model is designed with cooling built in, suitable for its rated maximum power. For example, the 30A BB18 you see here is designed with a body that can dissipate heat through its pin fins at a rate of up to 30 watts, continuously. And that is its maximum rated power. The fan-cooled FL250A BB50 has a fan to enable it to work at up to 250 watts, continuously. If, for example, you need to use such a sensor in a burn-in station for a week straight, these would do the job. Of course, common sense is always needed, and if an application is pushing some parameter close to its limit, then you might want to check with us. There are some exceptions, sensors specified for up to a certain power continuously, but up to a higher power for intermittent use for a limited time. For example, the L5150A that you see here can measure up to 50 watts continuously, but up to 150 watts for about a minute or so at a time. We clearly state in the specifications any guidelines that apply in such cases. Water-cooled sensors, similarly, can work continuously at their maximum rated power. Note that in many cases, if no water is flowing, but there is water filling the sensor to make thermal contact, you may be able to use such water-cooled sensors at a fraction of their full power, or at their full power but for a short time. Again, if you have a specific question, please do contact us.